Hello and welcome to this learning video. In this learning video, we are going to take very important problems of this topic, Z transform. So let us see this problem. So this problem says prove that Z transform of n to the power p is same as minus z times ddz of Z transform of n to the power p minus 1. Where p is any positive integer and hence we have to find out this and this. So let us concentrate on the first part. Okay, what is it? So in the first part we are talking about Z transform of n power p and Z transform of n power p minus 1. So let us first of all make use of definition of Z transform. Write down Z transform of n power p, write down Z transform of n power p minus 1, and then we'll see what we can do, okay, in order to get this result. So I'm gonna start with by the definition of Z transform. By the definition of Z transform, we have, what is it? Z transform of f of n is equal to summation n is equal to 0 to infinity f of n into z power minus n. Okay, now we can write Z transform of n to the power p likewise minus n, right? And similarly we can write Z transform of n power p minus 1. So it should be is it okay up to this? Now you just see we have this Z transform of n power p and Z transform of n power p minus 1. Now we can think of the result. Okay, so if you can see the result, we have ddz of what? N power p minus 1, Z transform of n power p minus 1. I have written Z transform of n power p minus 1. So what I am going to do here is I am going to apply now ddz to this. Okay, so differentiating with respect to z, we get, what is it? ddz of n power p minus 1 is equal to, what is it? ddz of summation n is equal to 0 to infinity n power p minus 1 into z power minus n. Now just differentiate it. So when you differentiate it, you'll be getting summation n is equal to 0 to infinity n to the power p minus 1 into, what about derivative of z to the power minus n? This is minus n into z to the power minus n minus 1. So let me continue here now. So what is my left hand side? My left hand side is this, implies ddz of this is Z transform. Okay, ddz of Z transform of n power p minus 1 is equal to, what is it? ddz of this. Okay, we have already taken derivative. Okay, so what I am gonna do here is we'll write this as summation n is equal to 0 to infinity. This can be written as n power minus p and p minus 1, and this is n power plus 1, law of indices, and minus sign I am taking outside, into, this can be written as z to the power minus n upon z to the power 1, taking this minus 1 in the denominator. Okay, now this can be written as this, just a minute, minus n minus 1. Okay, that's correct. So this is minus 1 by z into summation n is equal to 0 to infinity n to the power p minus 1 plus 1 get cancelled, n to the power p into z to the power minus n. And what is it? Z transform of n to the power p is summation n equal to 0 to infinity n to the power p into z to the power minus 1. So I'm gonna replace this by minus 1 by z into z to the power z transform of n to the power p. So I can give it to be 1 and I can write here by 1. Okay, now we have the left hand side ddz of z transform of n to the power p minus 1. So just multiply this to here and you will be getting minus z into ddz of z to the power z of z transform of n to the power p minus 1 is equal to z transform of n to the power p, and that is what we want. That is z transform of n to the power p is same as minus z into ddz of z to the power z transform of n to the power p minus 1. You can see this is the result we wanted to prove. Very simple. Okay, so this is just the first part. Now look at the second part. So in the second part we have hence deduced that this and this. So I'm gonna prove one result from these two and the other one you have to solve. So say this is to be my equation A. Now the second part, I will do now the second part. So see the second part now. In the second part, I am going to prove the first one. To prove or to find z of n is equal to z upon z minus 1 square. Okay, we have this result and we have to find out this result. Okay, so what we need to do, this is z transform of n power p, this is z transform of 1, so we can write put p is equal to 1 in equation A. We get what we get, z transform of n power 1 is equal to minus z into ddz of z transform of what is it, n power p is equal to 1, so 1 minus 1 0, so n power 0 which is 1. Okay, and you know what is z transform of 1, so this is minus z into ddz of z transform of 1 is z upon z minus 1. Okay, z transform of 1 in the very first lecture we have seen this. Okay, so let me check this one. Okay, yeah, so this is minus z into, take out derivative of this. We have also seen the quotient rule of this in the earlier video lecture, so not gonna repeat the same. So this is z minus 1 whole square, then this is z minus 1, derivative of numerator is 1 minus z into derivative of z minus 1 is 1. So this is minus z into z minus 1. Okay, z minus 1 minus z, so this is 1 upon z minus 1 whole square. Mod of z should be greater than 1. Therefore, z transform of n is, this is minus 1. So this is z upon z minus 1 square. Mod of z greater than 1. And it's all done. Okay, z transform of n is z upon z minus 1 whole square. Now it's your task to deduce the second result. What you need to do is you just need to put p is equal to 2. Okay, and accordingly you have to solve. So I hope this problem is clear to you, and you have to do the second part and this is what we have in this learning video. So thank you for watching and keep learning.